Hello, fourth graders. It's Mrs. Orak, and I will be teaching your math lesson today. And I'm going to share my screen with you real quick to give you an idea of what our lesson will be on. Today, we are on lesson 5. The objective is use a circular protractor to understand a 1-degree angle as 1/360th of a turn. Explore benchmark angles using the protractor. Now, you most likely don't have a protractor at home. Yes, you can go get one at Walmart, but we did not supply you with one. I'm going to show you a website where you can use an electronic protractor. Also on IXL, at the end of this, I'm going to show you on IXL, there is a protractor on the lesson, so you'll be able to do that as well. And here we go. Let's go over some vocabulary words. 2 vocabulary words that we're going to be going over today in the lesson. The first one is protractor. So, of course, I had mentioned this before. This is part of our learning target. A protractor is a tool used to measure angles. So you're going to be using this in the lesson today and looking at it. And it measures angles, and sometimes, most of the time, it's measured in by tens, okay, if you're skip counting by tens. Sometimes, for example, when I'm using IXL and practicing those lessons, those lessons sometimes they measure them by 15s. So today's lesson, we're going to look at both. The next vocabulary word is degrees, and that's what we're measuring with protractors. We're measuring the degrees of shapes, the degrees of corners. Often we're measuring triangles, okay? But we can measure really any shapes, corner, or vertex. So degrees are a measure for angles. In this next video, you're going to see a circular protractor being drawn. I encourage you, as he is drawing it in the video, to draw it yourself on a piece of paper or in your workbook. And so what circular means is really just a circle, the shape of a circle, because most protractors are a semicircle, meaning they're cut in half. But there's also circular protractors. So we're going to take a look at both of those today.
So we're going to begin, though, by understanding what is a degree in the first place, okay? And we know that 1 degree, there we go, 1 degree is going to represent 1/360th of a turn, all right? So the idea would be a complete turn all the way around would be 360 degrees, and a lot of students understand that right from the get-go, that 360 degrees is a complete turn, but you don't have to have them just trust you on that. What you can do is say, well, let's start by drawing a couple of line segments that look like that. What do we have now? We have some perpendicular lines. So we have this and this are perpendicular. That means each one of these is a 90-degree angle. So let me label one of these, and I'm going to say, okay, that's a 90-degree angle. And then 90 times 4 is 360 degrees. So a complete turn, a complete rotation is 360 degrees. And each degree represents 1/360th of a turn, all right? So a quarter turn would be starting here and going up to here. Half a turn would be starting from here and going all the way over to here. That's 180 degrees because we did 90 plus 90. And if we wanted to go all the way around, that's going to be 90 plus 90 plus 90 plus 90. So that's 360 degrees. So now we can actually kind of make our own protractor if we wanted to. So we know that each one of these wedges is 90 degrees. So if I wanted to, I could take this wedge right here and I can estimate, and I won't be perfect, and that's okay. And I'm going to cut it into 3 pieces. And what did I just do? I just turned each one of these into 30 degrees because I did a 90 degrees and cut it into 3 equal pieces. If I wanted to, I could go over here. This is also 90 degrees, and I can cut it directly in half. Well, that's not exactly half, but pretty darn close. And what did I just do? Well, I just created 2 45-degree angles. Now, if I wanted to, I can take one of these 45-degree angles, and I can cut it into 3 pieces. 1, 2. And 45 degrees divided by 3, that gives us 15. So I can squeeze this in and call this, whoa, and call this 15 degrees, this 15 degrees, and this 15 degrees. So we're kind of making our own protractor here. It's not exactly perfect, but it's pretty good. Now, if I wanted to, I can go to my 30 degrees, and let's see if I can do this. I can take my 30 degrees, and if I wanted to, let's zoom in on this 30 degrees here, and I can erase this 30, but I'm not going to be able to erase it, so I'm just going to take it, and I'm going to cut it into 3 equal pieces. 1 and 2, 3, there. So now what did I just do? Well, I just created each one of these is 10 degrees. So you can see, and I'm going to label this 10 degrees, and now I'm going to zoom out, and you can see that a degree, 1 degree, is very, very tiny. If I'm already struggling with trying to draw 10 degrees here. In fact, if you look at it, 10 degrees and 15 degrees, the way I've drawn it so far, boy, they look very similar. That's because even 5 degrees is a very small amount. Anyway, so this is how we can begin the process of trying to estimate what a protractor would look like. We start with 90 degrees and we can cut them and subdivide them into smaller wedges. So this right here is 15 degrees. That's amazing to me. Well, let's get going. So what I've got here is I've got an angle. It's kind of right here, sitting right here. And then I've got a couple of different protractors. I've got the circular protractor here, and then this is a traditional protractor here. And even with the traditional protractors, there's a bunch of different kinds of protractors, but they're all basically used the exact same way. And I'm going to put this traditional one aside for a second, and I'm going to grab this circular protractor. And what's really cool about my circular protractor is I can make it big and I can make it small. Okay. Now, if it's too small, we can't read it. But here's the neat thing is unlike a ruler, like if you stretch out a ruler, all of a sudden you're no longer measuring inches, or if you shrink down a ruler, you're no longer measuring inches. The neat thing about a protractor is no matter how big or small your protractor is, you're still going to measure the correct angle. So here's the idea. You take this protractor and you'll notice that this protractor has a centerpiece and a point. I call that the target. And then it's got a 0 degrees somewhere. Even the traditional protractor, and I'm going to get this, the traditional protractor has a target. Here it is, here's the target, and here's the 0. So that's going to be common on every protractor. You're going to always have a target, and you're always going to have a 0 somewhere. All right, so let me get the circular protractor. And the idea is you put the target right here on the vertex of the angle, on the corner of the angle. And then you rotate your protractor so that 0 lines up with one of the legs of the angle. Boom. Pretty close right there. So now I can zoom in and I can see there that my angle starts here at 0 and it goes 10, 20, 30, 40, 50, 60, 70. That looks about to be exactly 75 degrees. So I can measure that and that says, all right, it's 75 degrees. Now the cool thing is, if I shrunk my angle down, all right, so we now know that the answer is 75 degrees, but if I shrunk my angle down, my protractor I mean, and I measure that right there, now you can see that the angle, and I'm going to have to zoom in, even though I shrunk my protractor, I still get the exact same measurement of my angle reading. So I'm going to start here at 0, 10, 20, 30, 40, 50, 60, 75. So both times, whether I use the big protractor or the small protractor, in both cases, I got 75 degrees. And that's kind of the neat thing to me about the protractors is that the protractors, it doesn't matter whether some people are using a big protractor and other people are using a small protractor. What, no matter what, whether you're using a big protractor or a small protractor, you're always going to get the exact same measurement, assuming you do two things. One, you put that target directly on the vertex, the corner, and you line up your protractor so that the zero, which right now is right here, so that the zero lines up on one of the legs of the angle.
I absolutely love the way he explains the circular protractor and the regular protractor. When I was a kid, or around your age, I remember first learning that no matter how big the protractor is, or no matter how small it was, the angle was still going to be measured, right? The same, because it's the angle. So I wanted to kind of show you guys that. Now, here is just a regular triangle, right? Well, it's an angle right now, it's not a triangle yet. And now if I take my protractor and I'm measuring that angle, no matter how big or small it extends out, whether it's the shape or the protractor, it still can be measured the same, okay? Because it's the angle we're measuring. So I can make that even bigger and bigger and bigger and bigger. Guess what? The angle in every single corner will continue to be the same, even though you expand it out. So to me, it's kind of crazy to think about. Now, if I change the shape completely and I make it obtuse, and all these are kind of sloppy, I apologize. If I make an obtuse triangle here, this is like probably about 100 degrees right here, because it's gonna be more than 90. No matter what, those angles are gonna stay the same, okay? Because I could even make it the same thing down here. This is just pretending if it were the same angle, okay? The angles would stay the same measurement, even though it's bigger, okay? So there we can go back and forth. I wanted to show you this pretty awesome website. It is called Math is Fun. Okay, so right here, and I'm going to link it as well. So it's mathisfun.com, pretty simple to remember. You probably have already been on this website at this point in your life. And on this link I'm going to give you, there is a tool that you can use, using a protractor tool. And it explains in this website how we can use the protractor tool. And they really are easy to use once you start using them. Now, what we're gonna do is look at this animation real quick. You're gonna see, I'm gonna go ahead and click play. You're gonna go and see the protractor, and they're measuring, okay? They're taking away the protractor. They're drawing a line because they're creating their own triangle, their own angle, truly, not yet a closed triangle. And then they're just using that tool to make a circle right here to measure and to draw the line. It's going to equal 50 degrees. All right, we know it's 50 degrees because if it were 90 degrees, it would be like an L shape, this way, L shape. And it's not quite there. It's 50 degrees. It says protractors usually have two sets of numbers going in opposite directions. Be careful which one you use. When in doubt, think, should this angle be bigger or smaller than 90 degrees? So anytime I forget 90 degrees, oh yeah, it's the L shape, okay? And if it's going to be bigger, I'm going to leave my thumb here, it's going to be bigger than 90 degrees, it's going to be obtuse angle. But if it's smaller than 90 degrees, it'll be the acute angle. All right, let's go ahead and take a look at this one. The first one we saw was an acute angle. This is going to be obtuse, meaning bigger than 90 degrees. Here we go. So they're using the protractor. They're finding the angle they want. They're using a ruler to draw a line. And since you don't have your own, this will be a good way for you to watch it. And then they're going to write 110 degrees. So that means it's just slightly over 90, well, slightly meaning 20 degrees over. This last tool on this website, that I want you to try, you can keep trying different shapes. So I can try all sorts of different shapes here. Okay, I'm gonna look at this shape. So I'm gonna zoom in for you. And take the protractor. I can move it around. I can also use the backward and forward keys on my keypad to move the protractor, because the key to the protractor is to make it the bottom line here flat with the line that you're against the angle you're trying to measure. All right, so that looks pretty flat. And remember in the video, you need to move the protractor over to the vertex, the corner. I'm going to move it over to C because I want to measure the angle C. So I'm going to move it right there on the corner, the vertex. And then what I'm going to do is I'm going to use my eyes here. I'm going to grab my pencil and show you. Use my eyes to see what's the angle here at C. Now here at C, I'm going to follow the line here, and I am noticing that this is not 90 degrees. It's less than 90 degrees because it's like this. And I'm seeing 50. It's not going to be 130 because 130 would be bigger than 90 degrees more. So it's definitely going to be 50. That's my guess right here. So I believe that this is going to be 50 degrees over there at C. Okay, I'm going to go ahead and clear my drawings. I'm going to go back to my mouse, and I'm going to go up here to where it says C and write 50 degrees. And oh, boom, you have one angle correct. Then you're going to keep trying that with all the angles. So go over here and measure B. And you may have to move your protractor to make sure it's nice and even with the line. And I'm going to go to B and take a look here and give it your best guess. What do you guys think? Remember, this is not quite 90. Or is it more than 90? What do you think? Looks like a little bit less than 90. Doesn't look like 100. I'm going to go with the 80 number up here. Looks like 80 degrees. So I'm going to come up here, and I am going to write that was angle B. Remember, we're measuring here. We're not yet at A. And my guess was 80 degrees. I have two angles correct. Here we go. Now, this is the silly part that's going to take probably the longest. You're going to, this way is fine. Okay, I'm going to keep holding down one of my keys. It's going to one of my forward keys or backwards keys, and it's going to rotate the protractor all the way around. Come on. Okay, then I click and drag, and I want to measure A. So get your little, what we call the center point, right? Get over to the vertex and get that line on the bottom where it says 0 right here, flat with the line. So I'm right at A, I'm pretty close. Now I'm going to make sure that I'm measuring it correctly. So I would say this is an acute triangle. So all these are going to be acute angles. So I'm looking here, I have A, 0, and then this is going to go up. It looks like here's 60, here's 40, in between that's got to be 50. So my guess would be that angle A is measuring 50. Well done. We did it. Boom, 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 half that. Perfect. I'm proud of us. We did great. Okay. So what you can do is see the measurements right here. Remember how they don't have to be perfect. If you're a degree off, see how my guess was 50 or my guesstimate was 50 and it says 51. Well, if it's within a couple degrees, that's totally fine because it's really hard to see those when they're so tiny, those little degrees. Then B, 79, it's 80, so pretty close. So you can keep trying a bunch of shapes. Some of them will be trickier than others. Here we are at your lesson 5 problem set for today. It says, number 1, make a list of the measures of the benchmark angles you drew starting with set A. Round each angle measurement to the nearest 5 degrees. Both sets have been started for you. I'm just going to have you ignore the nearest 5 degrees right now, okay? We did not create a set of benchmark angles, okay? We did not do that. So what you're going to do now is you are going to grab your problem set and work with me. I'm going to go ahead and grab black, so it's a little bit easier to see here on our problem set. Set A, 45 degrees and 90 degrees. Well, if you make a circle, this is gonna be our circular protractor, and you split it up into 4, right? This will be 40, and all this is 360 degrees. This is 90, 90, 90, 90, okay? Now, one of those needs to be 90. So I'm gonna go up here and say, well, I'm gonna grab my other color here. This line and this line are going to create 90 degrees. So you can just write this in your problem set, 90 degrees. Then I did that, boom. Now I have 45 degrees. Well, I already used that. So what I'm going to do is I am going to say, well, what's 90 split in half? 90 split in half is 45 degrees. So from here to here, I have 45 degrees. This right here is like my 0 point. The interesting thing about a semicircle protractor, just half of a circle, is that this goes from 0 to 180, and it can be back and forth. So you can go back and forth, okay? So it could also, the 0 could start here, and the 180 could go here. Because remember, 180 is half of 360. If I were going to measure all the way around, this would be another 90, so the whole thing would be 360. We're just looking at half of it. All right, now I'm gonna use a different color again. So I have two angle sets. I have this angle, which was 45, and then this angle, which was 90, so two angles. Go ahead and try 1B now that we have done 1A. Let's go ahead and skip number 2 and move on to number 3. List the angle measures from problem 1 that are acute. Trace each angle with your finger as you say its measurement. So my screen has moved down a little bit. So I'm gonna go ahead and move down here because I actually wrote these down already. So the 2 degrees that I had were 45 degrees and 90 degrees in 1A. So I remember that I had 45 degrees. Well, first let me do 90 degrees. So I had 90 degrees, okay, here. And then I had one that was 45, so half of 90, 45 degrees. And as I'm tracing with my finger, I'm saying that, oh, this is 90 degrees, this is 45. Now, I want you to circle the one that's, I'm gonna write it down as well. I want you to circle the angle that is acute. Remember, acute means less than 90 degrees. Think, think, think. If you guess this one, you're right. This one is small, it's cute. So it's going to be acute, this is right. Okay, so this is the answer on number 3. Let's move on to number 5. It says, we found out today that 1 degree, that little tiny circle is meaning degree, sign for degree, is 1/360th of a whole turn. It is 1 out of 360. Remember fractions? That means that 2 degree angle is 2 out of 2/360ths of a whole turn. What fraction of a whole turn is each of the benchmark angles you listed in problem 1? All right, so if I just look at one of the angles, I'm going to just be going back to 1A. One of the angles was 45 degrees. That means it was 45 degrees out of 360. And another one was 90 degrees. So the other one was 90 degrees out of 360. 360 is the whole here. Go ahead and do number 6 and 7 on your own, okay? And then number 8 says, if you didn't have a protractor, how could you reconstruct a quarter of it from 0 degrees to 90 degrees? So remember in the video, we learned that the hole here, if we're using a circular protractor, because it's circle, is 360 degrees. And it's split up into quarters. A quarter means 1/4. So each of these are going to be worth 90 degrees. Because 90 plus 90 plus 90 plus 90 equals 360 degrees total. What I want you to do today is make sure that you are practicing using a protractor and angles on IXL. Now you're going to notice here, I'm going to go to Z2. All right, Z2. What is the measurement of this angle? So you have to use your problem solving skills here. You're going to think, oh, well, that's not 90 degrees because it's tilted. Nope, if you tilt it back to where this line is here is flat, that it will be 90 degrees. Okay, all right, here's where the questions may get a little bit tricky. So what I like to do is just picture a circle like this. Now, if we're saying that this is 0 right here, then we're gonna go all the way over here. Remember, we're splitting it into 4s. I'm saying that this is the first fourth. So I'm gonna say that this is, what fraction of a turn is this angle? It is going to be 1/4 turn. What fraction of a turn is this angle? So when you grab your pencil and you practice, and you're starting here, okay? It's measuring over here. You draw my circle so you can picture. It's not gonna be perfect. It's kind of ugly here, okay? I'm saying it's not here, and it's not here. That would be 2/4, 3/4. I'm seeing that it's all the way over here because I don't see another angle. So that means it went all the way around. It ended up back there. So this should be, let's see if we're right, 1 full turn. We got it. All right, my friends, I'm going to have you take a look at this this reminder here. If it's 1/4 of a turn, that means it's just 90 degrees. That's why this square is there. If it's 1/2 of a turn, it means it's gone from 90 all the way to 180. And that's why there is a circular 0, 0 to 180. And then here you can see, you're thinking, oh, that's gotta be 1/4, but it's showing here on the circle that it's already gone. Let's say it started over here. It's already gone 1/4, 2/4, and 3/4. It's showing you here the angle that it's going all the way around. It reminds me, if you want to use the picture in your head of Pac-Man, it's like eating something, right? The Pac-Man monster is going from 0, 1/4, 2/4, and all the way to 3/4. So keep that in mind as you're doing your IXL lessons. Great job, fourth graders. I know that today is starting to get a little bit more in depth about what we've been learning about at the beginning. So really stick with it. Keep practicing. Get on IXL and practice, practice, practice. Remember to click on the button that says learn with an example so you know what to do for the whole IXL lesson. If you have any questions, please reach out to your teacher. And you guys have an awesome day, and I will see you next time. Bye.